Okay, welcome to 2.3, day 2. All right, today we're going to talk about the local minimum and local maximum, and those are also known as relative maximum and relative minimum, also known as relative extrema. Extrema. You'll see that on the next page. Okay, let's take a look at a technology-based example. Okay, so let's say that the instructions tell you that you need to use a graphing utility. That just means graphing calculator. Use a graphing utility to graph each function, or graph the function. I'm not going to do multiple examples. I'll just do one for you. Over the indicated intervals, over the indicated interval, and approximate any local maxima and local minima. Okay? Determine where the function is increasing and decreasing. Determine where the function is increasing and decreasing. Okay, so I'd like you to write that problem out because it's important that you have it in your notes. Alright, so the example I chose is this one. F of x equals x to the third minus 3x plus 2, and the indicated interval is negative 2, 2. Okay, so what does that mean? Okay, this is your domain. Okay, we're giving you a domain. And this is actually the function they gave you on the left, right? So you're going to turn on your graphing calculator and type this in as y1. Okay, I'll do it too. So let's pull up the graphing calculator. Alright, let's turn that sucker on. Okay, I've already entered my function. To get to that, by the way, you're supposed to press y equals right here. I should bring up this screen. Now, if you just press graph, you might see something other than what I see. I actually see a full graph, I see, lots of things. The indicated interval is very important. In this problem, they asked us to stick to the domain negative 2 to 2. Okay? So we have to stick to that. So what we're going to do is we're going to press second, and actually we don't need second. We're just going to press window. Don't press second. Just window. Oops. So just press window. Okay? A little hard with the stylus. These are your x min and your x max, the negative 2 and the 2. Those are x min and x max. So I'm going to type negative 2 here and positive 2 here. Okay? And then I don't really care about that y stuff. I'm going to go ahead and press graph now. Okay, so what's going on is it's more of a zoomed in version of the graph. Alright. Now you're supposed to imagine that the endpoints are not part of the graph. Okay? So I'm just going to try to kind of copy that graph as best I can. Alright, I think it looks something like this. I think I got it now. I'll leave my calculator screen. Okay, this is what I have. I'm going from basically negative 2 all the way to positive 2. Alright, and I think I need to take a peek again. It was high at x equals negative 1. It hits the x-axis at x equals positive. Okay, so it looks something like this. We're not counting that point. It goes up, passes down, hits the x-axis, and goes up. So I'm using open endpoints because notice they gave me these rounded parentheses. Remember what that means? That means we're not actually including those. So this, remember, means negative 2 is less than x is less than 2, right? That's what that means. Okay, so there's my little window. I saw it on the screen. And that's the first thing I was supposed to do. I was supposed to then find where I thought the relative max and relative min were. I believe this point is a relative max. It seems to be the highest point in its little region. It's increasing on the left, decreasing on the right. And this point over here I believe would be my relative minimum. It's decreasing on the left side of it, and then it starts to rise as you go to the right. Okay, so where are those points? Well, I can't get them exactly. I think they're -1 and +1. The only way to really know is to do some calculus, which we're not ready for. Okay, so what I'm going to do is I'm going to use some of these technology features. So I'm going to press trace. Okay? Press trace, it's right there where my arrow is. And then I'm going to press the left arrow until my little cursor gets to the highest possible point. Okay, so where's the highest point? Well, look here, the x right now is -1.06, and the y value is around 3.98. Let me go to the right a little bit more. Ooh, that's even closer to -1. And it's even higher now. It's almost 4, see? Okay, so I kind of moved around in this region, and I found that the biggest number for y right here that I could get was 3.9986. Other points weren't quite as high. So that seems to be happening at -1.02. So we just round that to the nearest tenth, and that's going to be -1. Okay, so I think that f of x has a relative max at x equals -1. Okay, now let's look at the minimum. I think it's a +1. Let's go back and look at the graph. Okay, so I'm going to move my cursor all the way over here. It's kind of hard to get over there. Sometimes you can just hold it down. Well, maybe that's more advanced calculus. Okay, getting close here. Looking at the y value, I'm trying to find when this is a minimum right here. So it's 0.1, 0.06, 0.03, 0.01. I'm looking at the y value. 0.001. Wow, that's getting really small. So I have a choice: 0.00134 or 0.00137. I'm going to go with this one. This is the smallest y I was able to generate using the trace button, and I can come over here and see the x. The x is 0.98. Let's round that to the nearest tenth. We're going to say 1.0. All right. So we're going to conclude that f of x has a rel min at x equals 1. You can also just tell kind of by eyeballing it. Okay? Alright, now, little comments here. Gotta make some statements here. This point right here is the point, -1, comma, and I believe the calculator was telling me 4. And this point is -1, comma, 0, if you remember from the screen. So I just want to say this. There's another thing you can say here to add to this. You could say the relative max value is 4, and you could say the relative min value is 0. So what I'm doing is I'm giving the y value also, and we call that the value of the function. Okay? So maybe a better way to word it is the value of the function at the relative maximum is 4. The value of the function at the relative minimum is 0. Okay, I also just want to say one other thing. There can be more than one rel max and more than one rel min on a graph. Okay? So if you have a graph that's more complicated, you don't have to do this example, but if you have something that has multiple peaks and valleys, right? Then your graph might look like this, see? You might classify this as a relative maximum, and this is a relative maximum. So there's two of them. And then this point as a relative minimum, like that. okay? And one more thing. Sometimes our endpoints on these graphs are open, right? Like in our previous example, we had the open bubbles on the end like that. Which means we don't really need to look at those points at all because they aren't really existent. But if they're filled in, we have to be very careful. Okay, very, very careful. You might have to look at an endpoint sometimes to determine if it's a relative minimum, a relative maximum. Okay, the good news about that last comment is that, the bad news is that certain people would, certain textbooks would not consider these blue points on the ends as relative minima, okay, even though they're the lowest points in their little respective regions. Some textbooks would classify them as relative minima. Okay, so the good news about this is that those endpoints are never asked about in our textbook, and they are never asked about on the AP exam for calculus even. So we don't have to stress out about whether we want to call these endpoints open or closed. Open, closed. It doesn't matter. We're not going to be asked about those endpoints. In these examples you're doing in the book, those are always open, so you don't have to worry about it. But I thought it was worth mentioning. So this has 2 relative maxima and 1 relative minimum. Okay, and then the last topic we have here is odd functions versus even functions. Odd functions versus even functions. Okay. This is a really important idea. Let's talk actually about even first. Okay? Even functions. So the defining property of an even function is that f of x and f of negative x are the same. Okay? They are the same. And so actually we probably would normally put the negative x on the left. I think our textbook does that. So it doesn't matter. I'm just saying that these are equal. Let me give you a quick example. Let's say that we're dealing with this function. F of x equals x squared. Okay? This is an even function. Why? Here's the reason. It is even because if you find f of negative x, right, that means you plug negative x in for x. And you simplify, it takes you right back to f of x again. So we started by trying to find f of negative x. We found ourselves dealing with x squared, which is the original f of x. See that? Okay, so you might have to rewind that to follow that. But that's the case. Okay? One of the properties, a property of an even function, the only property we need right now, is that it has the y-axis as a line of symmetry. As a line of symmetry. Okay? All right. So we'll do an example of that again in a minute. Let's talk about an odd function. So the defining characteristic of an odd function is that f of negative x does not produce the original function, but it produces the exact opposite of the original function. My example for this one is going to be the following function. F of x is 1 over x cubed minus x is odd. Let me show you why it's odd. Watch what happens when I try to find f of negative x. Why is this odd? Here we go. If I try to find f of negative x, I'm going to replace each x in the original problem. There's two of them, right? One here, one here. I'm going to replace it both with negative x. Okay, so what happens? I get 1 over, and this part, this just means negative x times negative x times negative x, which is negative x cubed. And then, of course, this part just means negative times negative x, or negative 1 times negative x. So that's just plus x. And if I pull out a minus 1 from the bottom, I get this. But what is this? This is just negative f of x. See it? This is f of x that we started with way back here. And there's a negative out in front of it now. Okay, so we just proved that this function that I gave you is odd. Okay? Alright, that's how you can tell. Okay, now some functions are not odd nor even. Okay? So here is a function that is neither odd nor even. Let me just write the function can be neither odd nor even. This can happen. Alright, so let's see how that could happen. Let's say I gave you a function, and it was x to the third plus 1 over x minus 2. Okay? This is neither odd nor even. Why? Because, let me show you why. If you find f of negative x, here's what happens. You take each x in the original problem and replace it with a negative x. Right? This gives me negative x times negative x times negative x. That's the first term. Then I have plus 1 over negative x. I just pull that minus out, make it this. Minus 2. Okay, so this cannot be even. This is not the same as f of x, right? So we can tell that f of x is not even. So let me just reiterate what that means. Because it didn't come out to the original problem, this is not an even function. We're not dealing with an even function. Also, it is not, this expression is not negative f of x either. Watch. If you pull a minus 1 out, you get x cubed plus 1 over x plus 2. See that? So I just took a negative 1 out of this thing. And it doesn't seem to be negative 1 times f of x. This is not f of x, see? Okay, so there's basically an example where it's neither. And that is one of the homework questions they'll ask you about. And the last thing I want to say about odd and even is this. It is impossible for a function to be both odd and even. It is impossible for a function to be both odd and even at the same time. Okay? And there's one more thing I did forget. Let's go back here. Do you remember I said here that a property of an even function is, one of the many properties of an even function, is that it has the y-axis as a line of symmetry. There's a sentence we can write for odd functions also. I did forget to write it. We're going to need it later. So let's just put it in our notes. And we'll use it later. And the sentence would go something like this. a property of an odd function, so we squeeze this in up above here, is that it has the origin as a point of symmetry. Okay? Alright. Move some of the stuff around here. I like that. That's okay. Don't need this stuff anymore. Alright guys, thanks for your patience, and hope you do well on the assignment. You can ask questions in class too, okay? And I have a couple little shortcuts I can teach you.